this is objective 35. We are going to solve quadratics by graphing. Similar to systems, we are going to learn 3 ways to solve quadratics. So today we're going to talk about graphing and what they look like and what the graphs look like. We're not going to hand graph today. We're going to do all of this in our calculator. And then tomorrow we're going to solve by factoring. Do we know how to factor? Yes, we do. We're going to review it later today and into tomorrow. And then finally, we're going to learn a formula to solve it. It's called the quadratic formula. Okay. So we're going to learn 3 ways to solve quadratics. Any questions on that? Now, one thing you may be asking is, what's a quadratic equation? You know a quadratic equation because the highest exponent you see will be a 2. You will see an x squared. If it does not have an x squared, it's not quadratic, okay? And in Algebra 1, everybody always gets these confused. But here's the thing that you need to keep straight. You're going to learn how to solve 2 types of equations in Algebra 1. You already know how to solve one. You know how to solve linear equations, which means x is to the first power. Everything that we have solved so far has been linear. X has been to the first power. Okay, then you're going to have quadratics. Okay, there's things to the third power and to the fourth power and to the fifth power, but we're not going to worry about those in Algebra 1. We're going to look at quadratics where x is to the second power. Okay, and so on here I'll put this little stipulation that a cannot equal 0. What happens if this were a 0? Then it cancels out your x squared, which means then it's no longer quadratic. If you didn't have the x squared, you would then be just left with x to the first power, which would then make it linear. So that's just a little stipulation in there that this is the form of your quadratic equation, ax squared plus bx equals c. That is a form, but it just tells us that a can't be 0 because then it wouldn't be quadratic anymore. Okay, a has to be something other than 0. Any questions about that? Okay. There are, like systems, there are 3 possible solutions. Now, what I need you to understand is that it's not linear. Linear equations become what shape? A line, right? Everything we've done so far has been linear, and everything that we have graphed so far has been a line. Okay? This is going to be a parabola. Okay? And please know parabola. That is not a parabola. That is a parabola. They say, Miss Corns, we're going to graph them there parabolas. That's what I hear. It's not a parabola. It's a parabola. Okay? And parabola, it's just the name of the graph. That's all it is. But it's a U or an N. Okay? That's what a parabola is. It is a U or an N. In a minute, I'll be able to tell you, you know a U, well, I'll go ahead and tell you now. You know a U because your x squared term is positive. If your x squared term is positive, it is a U. If your x squared term is negative, it is an N. Okay? That's how you know the difference between a U and an N. So, it is possible, normally when you graph, your graph will look something like that, okay? And in this case, the question is, where's the answer? Now, in a system, the answer is where they intersect, right? Okay? In a quadratic, it's going to be where it crosses the x-axis, okay? So, and in this case, how many times does it cross the x-axis? Here's your x-axis. How many times does it cross? Twice. It crosses once here. Why do I wanted red. And once there. Okay? Why don't we do this? Okay? So it's going to, well, the question is it going to be x comma y and x comma y? Possibly, but here's the thing. what's the y-coordinate? If you're on the x-axis, how many up or down are you? And if you're on the x-axis, how many up or down are you? 0. So you really technically don't need the y-coordinates. You really only need to figure out the x's, okay? And again, that's because you're solving for x, right? You're trying to figure out where it's crossing the x-axis, okay? The y-coordinate is always going to be 0. Okay, repeat after me. The y is 0. The y is always 0. In a quadratic equation, y is 0. You are looking for your x's. Okay, so in this answer, there are 2 solutions. You'd have 2 answers. Okay, then it's possible for you to graph, and it looks something like that. Okay, how many times does it cross the x-axis now? Remember, it says it doesn't cross it, Miss Corns. Well, it touches it. Does that make sense? It touches it. How many times does it touch the x-axis? Once. And we would call that what? What point would be the very tip of the point? You know that word. It starts with a V. The vertex. You've heard that, right? Okay. That's the vertex of a parabola, is the very tip-top point, or the very, very bottom point is the vertex. But again, in this case, you would only have one solution. And then it's possible for you to graph a line like so, where it doesn't touch it, not at all. So what's the answer? No solution. Very good. So in this case, you're going to have 2 solutions, 1 solution, or no solution. There won't never be a mini solution. Okay? You have 2 answers, 1 answers, or no answers. Questions on that? Okay, so let's look at example 1. Before I move on, let me go over this. On the SOL, they're going to give you probably a quadratic equation, and they will say, solve. And when they say solve, what do they mean? Find out where it's crossing the x-axis, okay? Then they might say, find the x-intercepts. What does that mean? Same thing, where it crosses the x-axis. And then it might say, find the zeros. And this is what your calculator, and this is probably might be one of the most popular types way to ask the question. Find the zeros, and basically that means find your x when y is 0. If you want to find your zeros, you're going to figure out the x when y is 0. Is that the same thing? Is when y is 0, is it where it's crossing the x-axis? Yes. So that's another way. And then they might say there's another way that you will learn, not in this class. There's a way in Algebra 2 that we talk about. It's called completing the square, where you actually have to take the square root. So it says find the roots of this. It's the same thing. So if they were to say find the roots of this, it'd still be the same thing. Find out where it's crossing the x-axis. Okay? So no matter which way they ask you, it's still figuring out where it's crossing the x-axis. Okay? Well, I would write them down just so you realize, because the SOL is going to ask you like all different ways to do the same thing. Does that make sense? And they're just making sure that you realize that all those different ways are the same thing. Does that make sense? Like one of them, they'll say solve this, and okay, you figure out where it crosses the x-axis, and the next one they'll say where's the x-intercept? Well, it's the same thing, where it crosses the x-axis, so forth and so on. Okay? So no matter which way, if you see a quadratic equation, most likely they are going to ask you, probably 99.9% of the time, they're asking you to figure out where it's crossing the x-axis. Okay? All right. So you won't need a graph paper because we're going to do this in our calculator, but I'm going to use the graph here in a minute to show you. So if you want to sketch the graph, you can. It's up to you. Okay? Now, we're going to put this in our calculator. In order to put an equation into our calculator, we need to have it in y equals. I don't see no y. Ethan says y is 0. So is this the same thing? Is that the same thing? Yes, it's the same thing. So as long as you have y equals, or if you have 0 equals, it's the same thing. So we're going to go to our calculators. Calculators. Move this over here. And we're going to go to y equals. We're going to put in x, and then you're going to use the square button down here. Okay? Minus, get you a calculator from in the back. Minus 8x, right here. Okay, x squared minus 8x minus 48. Okay? Just arrow down. It's just, yours is a newer version than mine. Mine's an 83, y'all's is an 84. Okay? Do I have everybody right here? You tell me when I can go on. Huh. Let me see what you got.
This is what mine does. When I push x squared, the square.
Let me see you do. X.
You have to push x and then x squared.
X squared.
No, you got to push X
Oh.
and then X squared.
Oh, okay. Yeah, I missed that.
Okay? You have to press your variable button first. X. All the X squared button doesn't. All the X squared button does is adds the square to the X. Okay? Any questions about that? Okay, so then we're going to hit graph. Now, I'm going to talk to you again. If it doesn't look like this, okay, then you need to press zoom 6 and zoom standard. Now, what's the problem here? It ain't a little loop thing. It ain't a parabola, right? Well, it is a parabola. We just don't see it all. So, like, if I'm right here taking a picture of Kelly's face and I only get half the face, what do I do with my camera? I need to zoom out so I get the whole picture. So, what we're going to do is we're going to use our zoom button. We're going to zoom, and we're going to press 3. You can arrow down to it, and then you got to press enter. And you're going to zoom out. Now, we see it goes all the way down and it comes all the way back up. And so some of you are probably thinking, you got to press enter. If you use the arrow, you have to press enter twice. If you use the 3, you only have to press enter once. Okay? All right. Whatever. As long as you got it. Okay? So, some people say, do we need to see the very bottom point? No, because we're not looking for that. As long as we can see our 2 zeros, you with me? Our 2 x coordinates where it's crossing the x-axis, that's all you need. Okay? Now, before I go any further, I want you to understand something. Okay? Imagine I'm going to draw a really kind of relaxed. No. Well, you can. It's up to you. I'm going to imagine, you might want to actually. I'm going to draw a really relaxed parabola. Okay, so kind of a fat one. So, you want this point right here. Now, I want you to imagine this parabola like a train track. Okay? The calculator is going to ask you to go left bound and right bound of this point in order to find this point. Now, if I am traveling along this train track, okay, where would left bound be of this point? Would it be down here, or would it be up above? Down. If I'm traveling to the left, does everybody understand that? Then I need to go down below it. Okay, and some people get confused because it's not really left and right, it's more like above and below. So left bound in this case, you might want to write that so you don't get confused with your bounds, is going to be down below it. And everybody says, how far down below it, Miss Corns? Just a little bit, okay, as long as you are below the point. Okay, then the calculator is going to ask you to go right bound. And right bound, if we are traveling to the right, it would be up above it. So above would be right bound. Okay, you'll need to know that in just a minute, I promise. Okay, we also need to find this other point. And so it's going to ask you once again, go left bound of this point. Where would left bound of the green point be? Up. If you're traveling to the left, it's going to be up above it. And then it's going to ask you right bound again. And so if you're traveling to the right, right bound's going to be down below it. Okay? So let's go back to our calculator. Does it matter which point you find first? No. So we're going to go to second calc. What choice do you think we will want? 0. Good, because we're looking for our zeros. Figuring out what x is when y is 0. Okay? So we're going to choose choice number 2, and we're going to press enter. And it's going to tell me left bound. Now I'm going to tell you, before you press anything, we have a little guest on our calculator. Okay? I say he's the spider pig because he's got legs like a spider and he's fat like a pig. Okay, if you want to name him whatever, we can think of a name for him. But I'm going to tell you that he is way down at the vertex right now. Okay, in order to get him where you need him to go, you're going to use your left button and right button. If you use the up and down button, you will fall off the train track. And it's kind of like one of those games. Have you ever played one of those games like where you have to like take the apple from neck to neck to neck, or you take the egg on the spoon? What happens if it falls off? It breaks. Yeah, but you have to pick it back up and start out, come back again, right? You've done those races, right? If you drop it and you fall off, you have to start all over again. So that's what's going to happen. So be sure you only use the left and right buttons. So I'm going to go find the left side first. For some reason, I always work left to right. I think it's because I live in America. But I'm going to travel to the left, and I see him. Oh, there he is. Doesn't he look like a spider pig? Okay. And so it's telling me to go left bound. So of this point, where was left bound of the far point? To the left was above. So I need to go above the point. And everybody says, how far above? As long as you are above the point, you're okay. Just a little bit is all you need. Okay, we're going to press enter. Then it's going to tell you to go right bound. So we need to travel to the right and go below the point. Just a little bit. And we're going to press enter. And then it's going to tell us to take a guess, and we're going to say, sure, why not? And it's going to tell you that our x is -4, and the y is 0. Okay, just stick with me. I'm going to do it again. Because it's telling you to. You got to. Did you not read underneath? Okay, so let me try again. Let's start again. Okay, one more time. I'm going to look at the same point this time. Okay, so I'm going to go to second calc. Make sure you're choosing choice 2, 0, because we're going to find our zeros. Now, I have to go left bound if I want to find my 0 because the calculator is telling me to go left bound. Okay? So I need to go to the left of the point. Okay? Which in this case, if we imagine this, yes, this looks straight up and down, but imagine it like I have my flat one here. Okay? To the left is going to be up above it. So I'm going to use my left button, and I'm going to go up above. Here's my point. I need to go above it because that's what it is. And I'm going to press enter. And then right bound, when I press enter, it tells me to go right bound. Does everybody see where it says right bound? When I go right bound, I go down underneath. And everybody says, why underneath, Miss Corns? Because if I look at this point right here on my parabola, if I'm going to travel on my train track to the right of it would be underneath it. Okay? And I'm going to press enter. And then once I tell it to take a guess, I press enter again, and then it tells me that my x is -4. Okay? Did you get it this time? Yes? No? Are you sure? Because if you still didn't get it, we're going to do lots of these. You're going to get much better at this. Okay? So, we'll get there in a minute. Look, we still got to find the other point, right? We've only found this point. I still have to find this point. So to find this point, I got to do it all over again. Yes? Did you put your, I'll be there in a minute. Okay? Here we go. To find the other point, I'm going to go second calc. I'm going to go down to 0 again. You got to start all over and do it again. And then you have to get your spider pig all the way over. He's got to travel the train track. So he's got to go all the way down and come all the way back up. Okay, you with me? So I'm going to use my right button, and I'm going to take him all the way down. And if I get lost, like if I'm at this point and I go, I don't know where he is, I am lost. Look, it tells you where he is right now. You're at 3, -63. What are you wanting? What are you wanting your y to be? 0. So I need to watch it, and if I'm getting closer to 0, then I know, and I look, I'm at -50, now I'm at -43, now I'm at -35. I'm getting closer to 0. If you get your y's all the way up into the 200s, and you're going 200, 300, 400, 500, and you're going, I can't find him. Well, obviously you can't find him because you're traveling the wrong way. You need to go back towards 0. You always want your y coordinate. If you want to get right there, you know the y coordinate is going to be 0. Okay, if you're on the x-axis. So, here we go. Let's take a look at this. Look at my picture over here. If I'm looking at this point, to the left of this point is down underneath it. So I'm going to press enter because I'm already there. And then to the right of it's going to be above it. So I'm going to press enter. And then I'm going to press enter again, and I get 12. Okay? Did you get 12 that time? How do we write our answers? And there's a couple ways that you might see on the SOL. So you need to familiarize yourself so that you know it's the same thing. One way is to actually put the points. So you could put -4, 0. That's 1 point. And then you could put 12, 0. So that would be one way to write your answers. You could also say x is equal to -4 and x is equal to 12. That would be another way to say your answer. Or you could put your answer in a set. Okay? That's with the brackets. And so I can put it in as -4, 12. This is not parentheses -4, 12. Could I do that? That would make the 12 the y. That would make you go -4 and up 12. And so you could not do that. That is a big no-no. So if you're going to put it in a set, that'd be okay, because then that way these both represent x's. That's an x and that's an x. Okay? So you will see it any of the three ways. You can write it as a set. You can write it saying x is this and x is that. And again, why don't we have to say what y is? Because y is 0, always. Okay? Or if you want to write it as a point, that is how you would write it. Okay? Questions? All right, let's look at another one. Yes, we will clear. All right, so can I put this into y equals? Why? Because 0 is y. Very good. Okay, so we're going to put this into our calculators. And we will have x squared plus x minus 12. Make sure you got it in correctly. Everybody got it in correctly. And you got to make sure you say minus 12 and not negative 12. Okay? And so you'll graph something like this. And so it still is a U. It's not a V. V's are actually absolute value graphs. That's what V's are. But this is still a U, but it looks a little more like, what's wrong with my graph? It's still zoomed out. So when it gets like this, you can go back. I mean, you can keep playing with it. And if you zoom out again, you know, it gets crazy looking, okay? I've already told you, if you want your graph to go back to normal, what do I hit? Zoom standard, zoom 6. Now you can zoom in and then zoom in again and then zoom in again and it'll take it back, but if you want it to go back to normal like this, you can go straight to zoom 6, zoom standard. Okay? So, this one's really easy to see. What are my answers? Negative 4, negative 1, negative 2, negative 3, negative 4, and 1, 2, 3. So that's your answers. But just so we can practice the left bound, right bound, let's go ahead and do it. Does everybody have a graph that's looking like mine? Yes? Okay. So here we go. We're going to go second calc. We're going to go down to 2. We want to find our zeros. Left bound, again, you got to find, right now, our spider pig, it's telling you he's at 0, negative 12. So again, use the left and right buttons. Okay. Again, get your y towards 0. He'll come up eventually. Okay. Where is left bound of this point? If I'm traveling to the left on the train, I'm going to go up above it. So, and I'm going to press enter. And then right bound's going to be down below it. Everybody good? And then when I press enter again, x comes out to be negative 4. You got it that time. Good. Okay, how are we doing, Miranda? You got it that time? Okay. Again, you have fallen off the train tracks. So you got to start all over. You are the person that dropped the egg on the spoon, and you got to start all over. Okay? So again, watch this, guys. If I go to second calc, let me just show you. Okay, eyes up this way so you can see. If I use my up and down, what if I get confused and I start going down? Like it won't go, and then I try to go, and then I end up hitting this, and well, mine's actually working. But it should drop you off the train track. Okay? Nick says it does. Kelly says it does. And so what happens when you fall off the train track? You have to start all over. You have to go back to second calc. You have to go back to 0. And you have to start all over again. Okay? If you fall off the train track. Okay? Right. Well, because so is mine, left bound. Because it's just telling me where I'm at. It's telling you where your spider pig. Right now he is at negative, he's not quite at -4. He's at -3.8 and he is down -1.1. But again, he'll move. Your left bound will move. It's just giving you the coordinates of your spider pig. Okay? All right. So on this point, left bound would be below. Right bound would be above. And when you click enter, you get that x is 3. Okay? And it says error. So again, oh, that's right. So what happens if you get your left bound and right bound mixed up? It says error bound means you went the wrong direction bound. You went the wrong direction right and left bound. Okay, so it won't let you do it if you go the wrong direction. Okay? All right. Questions. So the answer here would be x equals -4 and x equals 3. Okay? Or you could put the set. I would say this would be a very popular way to do it. Okay. Macy? Okay. I will be right there. Did you start all the way over? It sounds to me like you've fallen off the train track. Okay, hold on. Otherwise, not 88, but it's not equal to 0. So here's the thing. If I've got two things on this side, everybody agree I got two terms? And I got one term on this side, how can I get nothing in this hand? Move this over, and then I have nothing. So what do we need to do? We need to move the 88 over, so it'll become 2x squared minus 5x minus 88, because when it moves over, it changes signs, equals 0. So once it's solved to 0, you can then put it in your calculator and graph it. So you go ahead and do this. See what you can come out with. Thank you. Okay, so we get -5.5 for the first one. If I want to find the second one, second calc, down to 0. I'm going to arrow all the way down. And then I'm going to arrow all the way back up. He'll eventually get there. Okay, left bound would be below. Right bound would be above. Click enter. And x is 8. Okay, so you can say -5.5, comma 0 or 8, comma 0. Okay, or you can put it in brackets. Just make sure you don't write it as a point. Okay. Huh? It's both of them. This has two answers. It's both of them. I don't think so. I mean, I guess it could be, but just zoom out and it'll go quicker. Yeah. Yeah. Okay. Everybody all right? Getting better with it? Okay. We can name him Tootsie Roll, whatever. All right. So you solved this one. Okay. Okay. Shh. Please be quiet. I don't need all the commentary. So first thing I'm going to do is I'm going to move my -36 over, and it's going to become +36. So far, so good? Okay. Then when I graph it, y is going to equal x squared minus 12x plus 36. Okay? And so this is one of those ones where it only has one solution. It does have a solution. It's touching the x-axis, okay, but it only touches it one time. And I told you that one time is right at the vertex of the parabola, okay? So when you go to second calc and down to 0, in this case, I'm going to bring my guide down. And this one's fairly easy. Where would left bound of this point be? On the left side. Click enter. Where would right bound of this point be? On the right side. I think this one actually makes sense. He's on the right side. Click enter, and when I click enter again, I get 5.9999999. Some of you got 6.00000. How many got 5.99999? How many got 6.00000? I don't know why this is. For some reason, when it's only one solution, the calculator does not get right on it. It gets it at 0.99999 or 0.00000. But we know that 5.99999 is 6. So x is equal to 6. Okay. Left bound is on the left side. Right bound is on the right side, just like it should be. Okay. It'll give you 6. It'd be 6. Okay. So again, when you have one that looks like this, if you want to put this in your notes, just so you can have direction on here, on this side would be your left bound. That's on the left side. And then on this side would be your right bound. Okay. Questions? You think? All right, let's try it. Here's example 5. Is this one still quadratic? It's got the x, but it don't have no x. It doesn't have to, as long as it has x squared. If it has an x squared, it is quadratic. Okay? When you graph this, you can see where is it touching the x-axis. It doesn't. What might be people's most common mistake here? To give me the answer on the y-axis. And if I said, what's the y-intercept, then you would give me where it is on the y-axis. But in general, I'm not asking, if I say solve this, I'm not asking for the y-axis. I'm asking for where is it touching the x-axis. And in this case, it doesn't. So your answer would be no solution. Okay, and again, I think, did anybody actually do the 0, left bound, right bound? Yeah. And it says error on it, no sign change. Okay. Any questions about that? You sure?